Hi, my name is Arun, and I'm solutions architect with one of the best organization in the world, Rackspace Technologies. And these are my views on solution for database availability. To understand the availability options and capabilities in Azure SQL, you need to understand service tiers that we have already dig many times before. But these service tiers actually decide a lot of features. We have covered the architectures as well, but now this time in this video, we are going to talk about from availability perspective, how the backend architecture affects the availability, right? So the service tier you select will determine the underlying architecture of the database or managed instance that you deploy. There are two purchasing models to consider, DTU and vCore, and we are aware of both, right? So you can equate. Now we are hitting the service tier because DTU has a different naming convention. In DTU, we call it basic, standard, or premium, or we call general purpose and business critical. So that's how I have represented right here. Basic standard you can equate with general purpose, business critical as premium, and hyperscale we know it doesn't exist in everywhere except Azure SQL, so there is no comparison. So let's start with the general purpose first. Right here we have seen this particular architecture many times, right? uh, so let's get started. Database and managed instance in the general purpose service tier have the same availability architecture. That's why both the names are together. They just belong to the different DTU or vCore model. So what exactly happens here? Well, first, this application right here, it tries to connect to the server, right? Because whenever we create the database, there is a server that we have to create, the logical server, right? So the application connects to the server name, which then connects to the gateway right here, gateway. Okay. That points the application to the server to connect to, running on a VM. All right. So application tries to connect to SQL database. It hits the gateway ring. Gateway ring diverts this to the server, which is running on a VM or a running VM. With general purpose, the primary replicas uses locally attached SSD for TempDB, as you can see here. The data and log files are stored in Azure Premium Storage right here. Okay, so TempDB is SSD, but the data and log files on the Premium Storage, which is LRS, as you can see right here. Locally redundant storage, multiple copies in one region or data center. Why I say data center? Because of zonal thing, right? You got the point, right? So the backup files are then stored in Azure standard storage. You see the difference? Of course you can. Premium, because those are live, or for backup, the standard, saving the money, which is also RAGRS by default, or in other words, it's globally redundant storage with copies in multiple regions. So you see, there is an redundancy which goes up to multiple regions, or global rather. You do have a highly available solution, because if one of this VM goes down, it will another VM will spin up and all the data is there in the premium storage. It will attach this to the VM, and there you go. So you have the availability in the architecture there and there, and the redundancy globally because of the backup files, which are RAGRS. All right, so next service tier, business critical right here. We can see next one is business critical or premium, because both has the same architecture. Well, both uh, business critical or premium tier generally achieve the highest performance and availability of all Azure SQL Service tiers. What all are we talking here? All which are represented: general purpose, business, and hyperscale. This one, the middle one, business critical or premium, is the highest performance and availability. Business critical is meant for mission critical application that need low latency and minimal downtime, right? Whenever we go and talk about or create architecture, talk to the customer regarding the database or PaaS service or Azure SQL, whenever it's mission critical, so we always recommend, because this is what Microsoft recommends for premium or business critical tier or service tier, of course, which is expensive, but you need, it's a trade-off, right? So let's go ahead towards the architecture. Business critical or this premium tier is like deploying an always on availability group behind the scenes. Even you can see right here, I have write down as in business always on availability group. Okay. So in business critical, the data and log files are all running on a direct attached SSD, which significantly reduce network latency. As you can see, we have right here in all the VMs, and this ring right here representing the always on. But if you see here in the GP, this is the premium storage. So there is a network latency, but here it is not. And in this availability group, there are 3 secondary replicas. Okay. Now, this is something important but obvious. Yeah. Read scale out with one of the secondary replicas supports session level consistency. Pretty sure you are understanding where I'm going with this. So if the read only session reconnects, if the read only session reconnects after a connection error caused by replica unavailability, it might be redirected to a replica that's not 100% up to date with the read write replica, because it's asynchronous replication, right? That's why session, if there is a session, there is a consistency. If it breaks, it might hamper, right? Likewise, if an application writes data by using a read-write session and immediately reads it by using a read-only session, the latest updates might not immediately be visible on the replica. Now, don't worry, it doesn't take hours or days. It just takes milliseconds. But we are talking about instantaneously. So the latency is caused by an asynchronous transaction log redo operation. Okay. So we are good with this, or like, let's talk about this failover. If any type of failover occurs and the service fabric determines a failover needs to occur, failing over to a secondary replica, let's suppose this one goes down, it is going to here, it's going here. Now request will come to here, right? Secondary replica is failing over to a secondary replica is fast because the replica already exists and has the data attached to it. Now, if you compare with the general purpose, if this goes down, service fabric needs to figure out the capacity, spin up the VM, and then move, attach these and take care of the availability. So that's why this one is the highest performant and best availability architecture. That's why for mission critical. And you do not need a listener. Yes, in a failover, you don't need a listener. The gateway will redirect. Gateway, remember? Gateway, right here. The gateway will redirect your connection to the primary even after failover, because once it's failover, the secondary becomes the primary. This switch happens quickly, and then the service fabric takes care of spinning up another secondary replica. Because when it's down, it should have 4 VMs running all the time, right? All right, so that was your business critical or premium tier, but the interesting one, Hyperscale, is still pending. So let's go ahead and talk a little bit of Hyperscale. The Hyperscale service tier, we know, only available in Azure SQL database, so there is no comparison. The service tier has a unique architecture because it uses tiered layer of caches and page servers, as you can see right here. There is page servers right here, and we have caches, data caches, right? So it's a tiered, one tier, second tier. It's tiered layer of cache and page servers to expand the ability to quickly access database pages without having to access the data file directly. I hope you got the point. Because this architecture uses paired page servers, you can scale horizontally, as you can see, right? 1, 2, 3, horizontally. You can scale horizontally to put all the data in caching layers. This new architecture also allows Hyperscale to support databases as large as 100 TB. I hope you are getting the point, because data file is right here. This is in caching, which is horizontally scaling. Because it uses snapshots, nearly instantaneous database backups can occur regardless of size. Database restores take minutes rather than hours or days. You can also scale up or down in constant time to accommodate your workloads. It's interesting to note how the long service was pulled out in this architecture. The log service is used to feed the replicas and the page server. Right here, you can see log service. You see this arrow and then this arrow right here. A log service is used to feed the replicas and the page servers. Transactions can commit when log service hardens to the landing zone. So the consumption of the changes by a secondary compute replica isn't required for a commit. Unlike in other service tiers, you can determine whether you want secondary replicas. You can configure 0 to 4 secondary replicas, which can all be used for read scale. Okay. All right. So as in other service tiers, an automatic failover will happen if service tier determine if it needs to, but the recovery time will depend on the existence of secondary replicas. For example, if you don't have replicas and a failover occurs, this scenario will be similar to that of the general purpose service tier. The service fabric first needs to find a spare capacity. If you have one or more replicas, recovery is faster and more closely aligns to business critical, right? Business critical maintains the highest performance and availability for workloads with small log writes that need low latency. But the hyperscale service tier allows you to get a higher log throughput in terms of megabyte per second, provides for the largest database sizes, and provides up to 4 secondary replicas for higher level of read scale. So you will need to consider your workload when you choose between the two. Well, of course, if it goes on higher storage side, by default, it would be hyperscale because it supports up to 100 TB. That's why hyperscale. Now, this is the things that we talked about. Is we talked about their architecture availability because of the architecture of different service tiers. But apart from that, you do have a geo replication and auto failover groups. We did talk about these in previous videos, couple of. So after you choose a service tier and consider availability zone as applicable, you can consider some other options for getting read scale or the ability to fail over to another region, geo replication and auto failover groups. In SQL Server on-premises, configuring either of these options is something that would take a lot of planning, coordination, and time. But the cloud, Azure SQL, made this process Very easy. Just a couple of clicks and you're there. If you don't want to hit the click, use PowerShell and you're there. All right. Well, this is all about the availability. Well, thank you for watching. You guys have a good day. Bye-bye.